Have you ever wondered, what if the entire reality we see around us is actually far older than humanity has ever calculated? Hello again, and welcome back to SciSleep. I'm truly happy that tonight you are here once more. I hope that no matter how your day unfolded, whether it was busy, exhausting, or filled with endless worries, right now, all of those things can remain outside that door for a little while. Tonight, there is only you, me, and the distant stars. Before we begin our journey deep into the mysteries of time and space, let me ask you something first. Are you comfortable yet? Are you lying in your familiar bed or curled up on the couch beneath a warm blanket? Try adjusting your pillow slightly. Relax your shoulders. Stop holding so much tension. Let your hands rest naturally. Take a deep breath in and exhale very slowly. That's right, just like that. In this quiet space, we don't need to rush. The universe has existed for billions of years. It isn't going anywhere. It will patiently wait for us, even if you accidentally drift off to sleep halfway through. Honestly, that would be the most wonderful outcome I could hope for. Tonight, together, we're going to touch a question that seems, at first glance, to already have a clear answer. How old is the universe? If you open almost any textbook or search online, one number appears immediately, almost like an unquestionable law of nature: 13.8 billion years. 13.8 billion, an enormous number, isn't it? It sounds precise, trustworthy, like a neatly printed label attached to the edge of reality itself. 13.8? Not 13.7, not 14. That precision gives us a strange sense of comfort. The feeling that humanity has finally grasped one of the Creator's deepest secrets. But what if I told you that number may only be one chapter in a much larger book than we ever imagined? Recently, discussions within the scientific community have become a little louder. Not because scientists made some foolish mistake, but because the universe itself has begun sending signals back to us. Evidence that simply refuses to fit neatly inside the framework of 13.8 billion years. It's like finding an old photograph of your grandmother, but in the picture, she's holding a modern smartphone. It makes no sense. And yet, there it is, trying to measure the age of everything, while standing from inside that very everything is an almost absurd challenge. We are like tiny bacteria living on a leaf, attempting to calculate how long the forest has existed. We have no cosmic stopwatch, no God leaving behind a birth certificate in some hidden drawer. All we truly have are clues. Faint particles of light that traveled for billions of years just to touch our telescopes. The retreating motion of distant galaxies and the deep echoes left behind from the beginning of time itself. Tonight, I want to invite you to re-examine those clues with me. We are not searching for a dry number. We are searching for the truth hidden behind the light. Why did the James Webb Space Telescope keep scientists awake at night? Why do some stars appear older than the very cradle that gave birth to them? No need to rush. We have an entire night ahead of us. Now, allow your mind to drift away, far beyond this room, far beyond Earth, and backward through time itself. We will begin with what we think we know, only to discover how much we truly do not know. Are you ready? Let your breathing become soft, steady, and let us begin the first chapter of this journey right now. One, could our measuring stick be wrong? To understand why scientists are beginning to question the age of the universe, we first need to understand how the number 13.8 billion years was discovered in the first place. You see, there is no giant cosmic clock floating out there, ticking faithfully since the beginning of time. There is no diary written by the stars for us to flip back and read. Everything we have comes down to a word scientists love to use: inference. Inference means we are detectives. We look at what remains behind. We observe how galaxies are racing away from each other. We study the cooling temperature of space itself, and we analyze complex mathematical structures. It's like walking into an old abandoned house. You see thick layers of dust covering the bookshelves, cracks stretching across the walls, and you begin estimating how many seasons of rain and sunlight that house has survived. You never witnessed the laying of the first brick, but the traces left behind tell a story. But detectives can be wrong sometimes too, right? One misunderstood clue, one blurry lens, and suddenly the entire timeline of the investigation changes. The most important clue, the crown jewel of modern cosmology, is the cosmic microwave background, or CMB. Imagine looking at a photograph of yourself taken only hours after your birth. That's what the CMB is for the universe. Roughly 380,000 years after the Big Bang, the universe became transparent for the very first time. Before that, it was a chaotic, burning soup of charged particles where light couldn't travel far without constantly colliding, like trying to walk through an impossibly thick fog. But then, the universe expanded and cooled. The first atoms formed, and suddenly, light was finally set free. It began an unimaginable journey through the void, lasting billions of years, stretched by the expansion of space itself, until it eventually reached our antennas as faint microwave radiation. Do you know the story behind this discovery? It's actually a little funny. In 1965, two scientists, Arno Penzias and Robert Wilson, were working with a massive antenna in New Jersey. They kept detecting a strange static noise, a soft hiss coming equally from every direction. They tried everything to eliminate it. They even climbed into the antenna to clean out pigeon droppings, believing the birds were causing the interference. But the noise remained. It turned out it wasn't the pigeons. It was the echo of the beginning itself. A whisper from 13.8 billion years ago, still vibrating quietly in your room right now. From that glowing CMB image, scientists built a model designed to explain everything. They called it the Lambda CDM model. The name sounds dry and deeply scientific, but it became the holy scripture of cosmology. Lambda represents dark energy, the mysterious force causing the universe to expand faster and faster. CDM stands for cold dark matter, the invisible glue holding galaxies together. When scientists fed the CMB data into this model, the numbers began to dance, and eventually settled on one result: 13. 8 billion years. Everything seemed almost too perfect. It explained why galaxies were distributed the way they are, why space has a temperature of 2.7 Kelvin. It felt like a universal key capable of unlocking every cosmic door. But this is where things become interesting. The Lambda CDM model is incredibly successful, yes, but it also contains ingredients we don't truly understand at all. We call them dark matter and dark energy. But those are really just names we give to our ignorance. We know they exist, but what are they exactly? Why do they behave the way they do? No one knows for certain. And if even one small part of that framework changes slightly, if one tiny parameter about how dark energy behaved in the past is misunderstood, then the entire number of 13, 8 billion years could collapse like a sandcastle before the ocean waves. Let those thoughts drift through your mind for a moment. Don't try too hard to analyze them right now. Imagine yourself lying on a small boat, floating across a dark, endless ocean at night. You cannot see the shore. You cannot see the bottom. Only the reflections of stars shimmering across calm water. That is us. Tiny creatures attempting to measure the ocean of time using broken wooden rulers found aboard the boat. Feel this silence. Feel your breath moving in gently and flowing out peacefully. The universe is unimaginably vast, and sometimes that greatness makes our calculations seem almost innocent. But perhaps that innocence is exactly what drives human curiosity, isn't it? We always want to know whether we might be missing something. Confidence in the 13.8 billion year model began to shake. Not because mathematicians made mistakes, but because when we observed the universe using different methods, the numbers themselves began arguing with one another. It's like measuring the height of a child with a ruler, then later using the child's shadow beneath the sunlight to calculate the same thing. The two answers should match, but somehow they don't. The gap is large enough to leave scientists scratching their heads in confusion. This disagreement has a dramatic name: the Hubble Tension. Why does the universe's expansion rate today not match what it promised in the image of the early universe? Is our cosmic clock running too fast? Or is space itself performing a trick we've never noticed before? In the next section, we'll step directly into the center of this debate, a place where galaxies themselves begin to speak, accusing us of possibly underestimating the true age of this world. Relax now, close your eyes, and let me guide you deeper into the glowing darkness of the next chapter. 2. The Hubble Tension. The argument between cosmic clocks. Now, allow your mind to relax even more. We've just left behind the glowing baby picture of the universe filled with ancient microwaves. And now, we are entering one of the greatest crises in modern physics. Scientists call it the Hubble Tension. Sounds dramatic, doesn't it? But this tension does not come from loud arguments. It comes from the uncomfortable silence of conflicting numbers. It's like owning two incredibly expensive, incredibly precise clocks in your house. But when you look up, they show different times. Not by much, only a few minutes apart. But those few minutes become enough to make you question the entire concept of time itself. Why do we care so much about the expansion rate of the universe when discussing its age? Let me explain it as simply as possible. Pause, as if thinking. Imagine watching a video of two cars driving away from each other along a straight road. If you know how far apart they are now, and you know how fast they are moving, then you can mentally rewind the video to determine the exact moment they first touched at the starting line. That's exactly how we calculate the age of the universe. The speed at which galaxies move apart is called the Hubble constant. If this constant is large, it means the universe is expanding very quickly, meaning it took less time to reach its current size. If the constant is smaller, the universe expanded more slowly, meaning it needed more time to grow older. So, the Hubble constant is essentially the compass needle of time itself. But ironically, we currently have two different compass needles pointing in two different directions. The first clock is the cosmic microwave background we discussed earlier. This method observes the universe from its starting point. Scientists use highly sophisticated satellites like European Space Agency's Planck mission to map tiny temperature ripples in the early universe. From those ripples, they apply the lambda CDM model to predict how quickly the universe should be expanding today. The result from this clock is around 67 kilometers per second per megaparsec, a number that sounds very modest. And from this number comes the famous age of 13.8 billion years found in textbooks. Everything would remain beautifully peaceful if this were the only clock we had. But there is a second clock, a more direct method, more observational, and far more stubborn. It does not rely heavily on predictions or theoretical models. It simply looks at what is happening around us in the nearby universe. And this is where we must talk about the cosmic distance ladder. Imagine space as a vast, dark ocean, and astronomers as sailors attempting to measure distances between islands. They cannot use measuring tape, so they rely on standard candles. The first are Cepheid variable stars. Oh, these stars are extraordinary. They are like giant hearts pulsing rhythmically in the darkness. Their brightness changes in perfectly regular cycles. At the beginning of the 20th century, Henrietta Swan Leavitt, a quiet woman with extraordinary vision, discovered something remarkable. The slower a Cepheid star pulses, the brighter it truly is. That discovery changed everything. It allowed us to know a star's true brightness simply by counting its heartbeat. And once we know how bright it really is, compared to how dim it appears from Earth, we can calculate exactly how far away it must be. It's like seeing a 100-watt light bulb far away at night. Since you already know it's a 100-watt bulb, you can estimate whether it's 100 meters away or a mile away based on how faint it looks. Cepheids became the first rung of the ladder. The next rung takes us even farther, toward Type 1, a supernovae. Explosions of stars so unimaginably powerful, so bright, they can outshine entire galaxies. Because these explosions occur in nearly identical ways, with nearly identical brightness, they became reliable distance markers at the edge of the observable universe. And this is where the shock arrived. When scientists, led by researchers like Adam Rees, who won a Nobel Prize for discovering dark energy, used Cepheids and supernovae to directly measure today's expansion rate. The number they found was not 67. It was around 73. 73 versus 67. You might think, it's only a difference of 6 units. What's the big deal? But in cosmology, those 6 units are an abyss. It means the present-day universe appears to be expanding about 9% faster than our most successful model predicts. And this difference can no longer be explained away as measurement error, because our instruments, from the Hubble Space Telescope to the James Webb Space Telescope, have become far too precise for such a large mistake. Think about that for a moment. If direct measurements show faster expansion, then the universe reached its current size more quickly, which would make it seem younger than 13.8 billion years. But wait, what if we're looking at this from the wrong angle? What if our lambda CDM model is missing something? Some hidden ingredient in the past that changed how the universe evolved? What if the Hubble constant is not truly constant at all, but changes over time in ways we still don't understand? Perhaps the universe expanded very slowly for an incredibly long period before accelerating later on. If that's true, then our entire method of rewinding the cosmic video would be fundamentally flawed. The universe might actually require far more time than 13.8 billion years to create the structures we observe today. This is the true tension. It is not merely a disagreement between two numbers. It is a conflict between what we think we understand about the nature of space and time and what the universe itself appears to be telling us. Sometimes I wonder, are we being too arrogant when we assume a few equations can summarize tens of billions of years of cosmic history? Perhaps the universe is quietly laughing at our tiny rulers. Take a deep breath. You don't need to solve the Hubble tension tonight. Let the scientists in distant institutes worry about the numbers 67 and 73. Your only task, right now, is to feel this magnificent rhythm. The pulsing heartbeat of Cepheid stars, the endless echo of the CMB, the unstoppable expansion of space carrying galaxies farther and farther away. Everything in the universe is moving, and so are you. You are drifting, slowly drifting into the stillness of the night. The disagreement between these cosmic clocks is simply a reminder that this world still contains far too many wonders left to discover. That our knowledge is only a tiny spark of light floating within an endless ocean of darkness. And inside that darkness, there will always be room for the impossible. In the next chapter, we will leave behind the dry numbers and search for more tangible evidence. We will look toward the oldest artifacts, the stars and galaxies that existed near the dawn of time itself, and they will tell us a different story, a story about structures maturing impossibly early. But that is for a little later. For now, just rest. Close your eyes and listen to the whisper of the void. 3. Living museums within the heart of the galaxy. Take a deep breath and exhale slowly. Feel the weight of your body sinking down, drifting deeper into stillness. We've just traveled through numbers, measurements, and the complicated debates surrounding the Hubble constant. But sometimes, to discover the truth about the age of something, we don't need complicated equations. We simply need to look carefully at what already exists before our eyes. You know, in archaeology here on Earth, if you discover a dinosaur fossil buried inside a layer of rock, you instantly know that layer of rock must be at least as old as the dinosaur itself. The universe works the same way. Astronomers have a field called stellar archaeology. Instead of using shovels and brushes to dig through dirt, they use lenses and spectrometers to dig through light. They search for the oldest surviving objects, stars that witnessed the first light awakening inside the void. These stars are like living museums. They are not trapped silently behind glass displays. They are still burning, burning quietly and patiently within the darkness of the Milky Way. They are survivors, witnesses that endured billions of years of cosmic change. Have you ever wondered what a star might look like after living nearly as long as the universe itself? It isn't brilliant and proud like young blue stars. Usually, it is small, dim red, carrying an almost strange humility within it. And yet, that humility may be the key to understanding whether the cradle of 13.8 billion years is truly large enough to contain them. There is one star, a name astronomers often speak with both reverence and confusion, HD 140283. But let us call it by its more familiar name, Methuselah. In ancient legend, Methuselah was the longest living human being. And this star is much the same. It lies only about 190 light years away from us, incredibly close by cosmic standards. It races through our region of the galaxy at astonishing speed. But what made Methuselah famous was its age. Roughly 10 years ago, the first measurements produced a result that stunned the scientific world. 14.5 billion years. Do you see the problem? 14.5 billion years. If our universe is only 13.8 billion years old, then how can a star be older than its own mother? How can a cake come out of the oven before the oven itself was built? At the time, it caused a true scientific earthquake. Were our measurements of the Big Bang wrong? Or was our understanding of how stars burn fundamentally incomplete? Imagine how scientists must have felt. It was like discovering a coin minted in the year 1900 inside a clay jar buried in 1850. A direct contradiction against logic itself. But then, science began its familiar process of self-correction. Astronomers took a closer look at Methuselah. They realized it contained an incredibly low amount of metals. In astronomy, anything that is not hydrogen or helium is considered a metal. The earliest stars formed from the purest ingredients left behind by the Big Bang, so they contain almost no iron, no oxygen, no carbon. Methuselah belongs to that ancient generation, born from a universe still far too young to be enriched by supernova explosions. After refining its distance measurements using the Gaia spacecraft and improving our understanding of how quickly hydrogen burns within its core, Methuselah's estimated age was lowered to around 14.27 billion years, and eventually to roughly 13.7 billion years, plus or minus a small margin of error. In the end, it finally managed to fit inside the 13.8 billion year universe, a last-minute rescue for modern cosmology. But you know, even though it is no longer officially older than the universe, the fact that a star could exist so close to the beginning of time remains deeply uncomfortable for our models. It means this star must have formed incredibly quickly, incredibly early, almost immediately after the fog of the Big Bang cleared away. It stands there, at the edge of time itself, as if whispering to us, "You still don't fully understand me, and perhaps you don't fully understand my mother either." Now, let's pull our gaze away from Methuselah and look wider. Instead of focusing on individual stars, let's look at entire populations of them, globular clusters. These are among the most magnificent structures in the universe. Imagine hundreds of thousands, even millions of stars, compressed together into a gigantic sphere of light. From far away, they look like handfuls of crushed diamonds scattered across the velvet darkness of space. These globular clusters do not live within the Milky Way's disk, where young stars are still being born every day. They exist in the galactic halo surrounding our galaxy. They are like ancient villages isolated upon distant mountaintops, places where time itself seems to have stopped billions of years ago. How do we know they are ancient? Scientists examine something called the turn-off point on their temperature brightness diagrams. It's actually a beautiful method, because all the stars within a cluster formed at the same time from the same cloud of gas. They are like classmates born in the same year. The biggest stars, the reckless ones, burn through their fuel quickly and leave the classroom first. Smaller stars, more careful and efficient, remain behind much longer. By observing which stars are beginning to leave class, scientists can calculate how old the cluster truly is. Again and again, the numbers settle around 12, 13, and sometimes as high as 13. 5 billion years. You see, all these cosmic artifacts are pressing against the limits of time itself. They corner the universe into a narrow space. They are saying, you cannot claim the universe is only 12 billion years old, because we have existed longer than that. The agreement between stellar ages and the universe's age from the CMB is considered a major success, but it is also a fragile balance. Just one discovery of a slightly older globular cluster, and the entire lambda CDM model could require rewriting from the beginning. Are you still listening to me? Let the images of those glowing stellar spheres drift gently through your mind. Imagine yourself standing inside one of those globular clusters. The night sky there is not dark at all. It blazes with thousands of nearby suns, ancient golden light, wrapping around you from every direction. There is no concept of day or night there, only eternal existence. In our busy world, a year feels long. An entire human life feels immense. But for these stars, a billion years passes like a single blink within the void. Feel the peace of belonging to that magnificent flow of time. The atoms inside your body were forged within the hearts of these ancient stars. You are literally the dust of those cosmic museums. Relax your body completely. Feel the support of the ground beneath you, of your bed. You are safe, protected by the very history of the universe itself. Everything has its moment, and your moment right now is simply to rest. But before you completely drift into dreams, remember this. The universe still holds an even greater secret. Because when we look using our most advanced eyes, our newest space telescopes, we do not only see ancient stars, we also see very young galaxies, carrying the maturity of adults. Why do the children of the universe already seem able to read and write the moment they are born? The answer waits in the next chapter, when the James Webb Space Telescope opens a new era. Shocking, beautiful, and deeply unsettling. Sleep well, if you have already begun dreaming, and if not, simply let my voice continue carrying you onward. Four, the James Webb Space Telescope and the cosmic earthquake. Now, after feeling the presence of the universe's oldest stars within your own skin, let's travel even farther. Beyond globular clusters, beyond anything visible to the naked eye. We are about to speak about a technological wonder, a gigantic eye humanity launched into space to pierce through the darkness itself. The James Webb Space Telescope, or simply Webb. Imagine Webb for a moment. It looks unlike any telescope you've ever seen. It carries a massive golden mirror built from shimmering hexagons, like a divine honeycomb floating through space. Right now, It drifts near a location called L2, about 1.5 million kilometers from Earth, where darkness is absolute and the cold is eternal. Why is Webb so important to the question of the universe's age? Because Webb sees the world through infrared light. You see, because the universe is expanding. Light from the most distant galaxies has been stretched over billions of years. When light stretches, its wavelength becomes longer, shifting from visible light into infrared radiation. Webb is like a machine traveling through time. It does not merely look deeper into space, it looks backward into history. It hunts for the very first photons that began their journey billions of years ago, particles of light carrying memories from a universe that was still only a child. Before Webb launched, cosmologists already had a fairly neat story describing how the universe evolved. We believe that after the Big Bang, the universe needed a long time to cool down, for gravity to slowly gather the first clouds of gas, and then, very gradually, tiny, distorted, faint galaxies would emerge. It was supposed to be a slow process, like a child taking years to learn how to read and write. But then, Webb opened its eyes, and that neat storyline suddenly shattered. During Webb's first months of data collection, the astronomy community experienced a genuine shock. I still remember the headlines from scientific journals back then. Phrases like, "a cosmic earthquake," "mild panic." Webb discovered galaxies. Galaxies that were unbelievably bright, unbelievably massive, existing in places where there should have been almost nothing at all. Systems like JADES-GS-Z 13-0 appeared brilliantly luminous when the universe was only around 300 million years old. 300 million years sounds long to us, but within a 13.8 billion year history, it is barely the blink of an eye. It's like walking into a kindergarten, and instead of seeing crawling infants, you find 80-year-old men calmly playing chess. These galaxies were not tiny or chaotic. They possessed clear structures, contained billions of stars, and most importantly, they were filled with dust and heavy elements. And this is the key point. Cosmic dust and elements like oxygen and carbon do not simply appear out of nowhere. They must first be forged inside stars, then scattered into space when those stars explode. That process requires time, a great deal of time. Seeing dust and heavy elements so early means multiple generations of stars must have already lived and died before then. So the question becomes, where did the time come from? If we continue trusting the age of 13, 8 billion years, then the early universe must have operated with absolutely insane efficiency, like a newborn child solving advanced calculus and writing novels immediately after birth. Or perhaps we calculated the age of the universe incorrectly. Maybe the true beginning lies much farther back than we thought. Perhaps the universe is not 13.8 billion years old, but 26 billion years old? A number proposed by Rajendra Gupta from the University of Ottawa in an attempt to explain Webb's discoveries. Imagine that for a moment. If the universe were twice as old as we believed, then the rapid maturity of these galaxies suddenly becomes reasonable. They would have enough time to grow, to create dust, to form supermassive black holes. But accepting that possibility would force us to discard nearly everything we currently believe about the cosmic microwave background. An enormous trade-off, an incredibly painful price for understanding. The universe truly seems to be playing hide and seek with us. It hands us a new puzzle piece, but the piece refuses to fit anywhere within the old picture. And beyond those brilliant galaxies, Webb discovered even more confusing monsters, primordial, supermassive black holes. You know, supermassive black holes usually sit at the centers of giant galaxies, like our Milky Way. To grow into billions of solar masses, a black hole must eat. It consumes gas, dust, and unfortunate stars wandering too close. But black holes cannot eat infinitely fast. Just as you cannot pour an entire liter of water through a tiny funnel in 1 second, matter will overflow. In physics, when a black hole feeds too rapidly, it emits intense radiation. And that radiation pushes surrounding material away, limiting further growth. This is called the Eddington limit. And yet, Webb discovered gigantic black holes existing astonishingly early in cosmic history. How did they grow so quickly? Could they somehow violate the Eddington limit? Or did they begin life from enormous seed black holes right from the beginning? Every clue Webb reveals seems to point in the same direction. The early universe was far busier, far hotter, and far more efficient than humanity ever imagined. It was not a child slowly growing up. It was an explosion of creation from the very first moments. Feel that vibration. A universe overflowing with contradictions. A universe that, every time we believe we understand it, throws an even larger mystery directly into our faces. Now let those numbers and theories drift away from your mind for a while. You do not need to be a physicist to feel this wonder. Simply imagine Webb, that small, golden mirror, floating alone within the freezing void. It is looking on behalf of all humanity. It is trying to read the very first pages of the book of existence. Your breathing. Let it become softer now. Whether the universe is 13 billion years old or 26 billion years old, it still remains the cradle holding all of us. The contradictions within science are actually the beauty of curiosity itself. We become confused because we are touching the very limits of human understanding. Relax every muscle in your face. Allow your eyes to rest. Perhaps tonight, within your dreams, you will drift through those primordial galaxies Webb has already seen. Cities of brilliant light floating within the original darkness, where everything first began. Do not worry about who is right or wrong. The truth remains there, silent and patient. And as we move deeper into the final chapters of tonight, we will not only look at what Webb discovered, we will explore the boldest ideas imaginable, hypotheses capable of changing our entire concept of beginning and end. But for now, simply let Webb's golden light guide your sleep, peaceful and still. Five, hypotheses of another universe. Relax, completely relax. You are drifting freely through rivers of thought. We have explored conflicting numbers, ancient stars, and the prematurely mature galaxies revealed by Webb. There is a strange feeling, as though we are trying to solve a puzzle using pieces that do not belong to the same box. So, what if this box itself exists inside a larger box? What if the beginning we trust so deeply is actually only a transition point? It is time for us to become a little brave, to step beyond the boundaries of what can be observed. We are entering the land of hypotheses, where mathematics becomes the language of imagination. You see, in science, When a model no longer explains reality, we do not immediately discard it. We first try expanding it. We ask ourselves, could there be a missing ingredient? A hidden component that existed during the first moments of creation and changed the entire game? Allow your mind to open, as vast as space itself. Let's talk about an idea receiving tremendous attention recently: early dark energy. We already know about present-day dark energy, the mysterious force accelerating cosmic expansion. But physicists like Mark Kamiankowski and Vivian Poulin have asked an intriguing question. What if dark energy once had an older sibling? A temporary form of energy that appeared very early, then vanished forever. Imagine the newborn universe as a runner standing at the starting line. In the standard model, the runner begins moving at a stable pace. But what if, the instant the gun fired, an invisible force suddenly shoved the runner forward? A tremendous push lasting only a brief moment? That shove is early dark energy. It would cause the universe to expand dramatically faster during its earliest phase, before the cosmic microwave background even formed. If this hypothesis is correct, then the standard ruler we've trusted for decades may have been distorted from the very beginning. A tiny alteration during those first moments could explain why today's expansion rate appears higher than predicted, and it would indirectly change how we understand cosmic time itself. Perhaps it would not make the universe tens of billions of years older, but it would make cosmic history far more dramatic. It suggests the universe did not simply grow up. It experienced turbulent phases of adolescence we never knew existed. Can you feel the vibration of that push? A mysterious energy, appearing suddenly, changing everything, then disappearing back into darkness, leaving behind a puzzle destined to haunt us forever. But there is an idea even bolder than that. An idea that makes the concept of the universe's age almost meaningless: cyclic cosmology. This hypothesis proposes that the Big Bang was not the true beginning of time and space from nothingness. Instead, it was a big bounce. Imagine the universe as an enormous lung, breathing. It expands outward endlessly, then contracts. Contracts until it reaches an extreme state of density and heat, before bouncing outward once more into another Big Bang. Roger Penrose, Nobel Prize-winning physicist, proposed a beautiful theory called conformal cyclic cosmology. He suggests that when the universe reaches the farthest limits of expansion, when all matter has decayed and only light remains, time and distance themselves lose all meaning. And in that strange final state, the end of one universe may mathematically connect perfectly with the beginning of another. If this is true, then how old is our universe really? 13.8 billion years? Perhaps that is merely the age of the current breath. Reality itself may have already existed through millions, billions of cosmic breaths before this one. An endless chain of deaths and rebirths. You are lying within one breath of the universe. You are living inside a single moment of eternity. Does thinking about that, Kishti, make you feel calmer? That perhaps we are not temporary accidents drifting through the void, but part of a dance with no ending. Every atom inside your body may have passed through countless Big Bangs before, and may pass through countless more afterward. Time is not an arrow. Time is a circle. Allow your breathing to merge with the breathing of the universe. Expand, inhale, and contract, exhale. You do not need to understand all of Penrose's equations. You only need to feel the greatness of the idea itself. A universe without a true beginning. A universe always present, always transforming, but never truly disappearing. Feel the heaviness of your eyelids. Every worry about aging, time, and the shortness of human life suddenly becomes so tiny beside this endless cycle. We are travelers resting briefly at one station within time itself. And this station, with all its glowing galaxies and unsolved mysteries, is a beautiful place to lean back and rest. Relax. Completely relax. Whether the universe is older because it grew differently than we expected, or because it has already lived many lives before this one, its purpose still leads us here. To create a space where life could bloom, where eyes could look upward, and where a mind could slowly drift into sleep tonight. Just a little farther now, and we will gently bring everything together. But for now, let yourself melt into this infinity. Sleep now, my friend. Darkness is not emptiness. Darkness is where all possibilities are born. And so, our journey tonight is slowly coming to an end. Together, we traveled through the whispers of the cosmic microwave background, the tension of the Hubble constant, the lonely star Methuselah, and the brilliant galaxies newly revealed by Webb. We asked whether the universe might truly be older than we imagined. Pause 3 seconds. And perhaps the answer does not exist inside a precise number written on paper. Whether the universe is 13.8 billion years old, or 26 billion years old, or an eternal cycle without beginning or end, none of that changes one miraculous truth. That right now, you are here. You are part of this magnificent story. You carry within you the ashes of the oldest stars, and also the curiosity of future generations yet to come. The universe may appear ancient, enormous, and sometimes cold, but it is also deeply warm, because it spent billions of years preparing for this exact moment. The moment where you could lie here safely and peacefully. Now, let all the knowledge, hypotheses, and numbers slowly drift away. You do not need to remember anything. You do not need to solve the contradictions of physics tonight. Let your mind become like a cloudless night sky, empty, still, peaceful. Feel the heaviness of your body one final time, from the top of your head all the way down to your heels. Every muscle has finally been released. Your breathing now is so soft, like a gentle breeze gliding across the surface of a quiet lake. Stop trying to control it. Let your breath discover its own rhythm naturally. The world outside may still be turning. Galaxies may still be expanding. Scientists may still be debating. But here, inside this room, beneath this warm blanket, time has stopped. Only pure rest remains. Thank you for trusting Sleep and traveling beside me tonight. Your presence, whether awake or already sleeping deeply, means more to me than you know. If these stories about the universe helped lighten your heart, remember that you can always return here whenever you need a peaceful place to rest. And now, just go. Drift into the land of dreams, where there is no distance, no time, only the absolute freedom of the soul. Sleep deeply now, traveler of the stars. May your dreams become magnificent, as endless as the Milky Way itself. Good night, and goodbye from Sleep.